Hello, folks. Quick question. Do you really need to spend $200, $300, $500 or more for a power cable for your hi-fi audio amplifier to get the best sonic quality out of it? That's a good question. I'm Professor Fiore, and we're going to chase that down in just a second. Greetings, folks. Just what is the deal with high-fidelity power cables for your amplifier? Now, I want to be clear. I'm not talking about loudspeaker cables. I'm talking about the cable that plugs from the wall socket into the back of your amplifier. Well, the claim is very simple. If you replace the stock power cord, which is typically 6 feet, maybe 2 meters long, if you replace this with a quote-unquote upgrade power cable, which might set you back $200, $300, $400, $500, you will have an increased audio experience. If you take these wires apart, you'll find out that they will use certain kinds of, proprietary construction techniques. They might use Litz wire. They might use special wires for certain frequency ranges, just like you would have a multi-way loudspeaker. You got a tweeter, a mid-range, a woofer, so they're going to do the same thing for the AC power cable, right? They might shield the cable, and like you would expect on a professional balanced microphone cable, something like that. What's the evidence? You will hear personal testimony that says, oh, yeah, I took this new cable and I plugged it in, and, they'll usually say there's a quote-unquote burn-in requirement, right? You got to listen to this for 20 hours or 50 hours or 100 hours or whatever the heck it is before you can actually hear the difference. Whenever I hear that, I immediately start smelling BS. A burn-in requirement. Seriously? It's copper wire. You have to quote-unquote burn it in for it to actually work? All right? Now, can we just please go into the physics of this? Personal testimonials are one thing, right? But the underlying science should give us some idea. Now, I know there will be people, this is always the case, that will say, hey, you can't talk about this unless you actually own one of these things and listen to it. Well, that's not really true. Think about it for a second. What if somebody came out and said, hey, I designed a special hat. This hat will prevent injury if you wear it and a 16-ton weight falls on your head. Because this hat is a special construction. It's got this carbon fiber shell and high-impact plastic interior and special bumper things and all this other stuff, right? Do I actually have to go out and buy this special hat and stick it on my friend's head and then release the 16-ton weight and see if he survives? No, I don't actually have to do that because I understand the physics of what's involved. I don't care what the hat is. I don't care if it's made out of Kevlar, carbon fiber, whatever the heck it is. It's not going to save my friend from being turned into a pancake, all right? Forget about it. Personal testimonials are only good up to a certain point. What we would like to do is maybe have a double-blind test. And interestingly, I've actually heard people say, no, you can't do a double-blind test because the apparatus that you would have to switch back and forth between your original and the item under test, that itself will change the quality of the sound. So you're actually creating a scenario where you can't test it. Well, sorry, I don't buy that. There is a well-known cognitive bias, right? Researchers, psychologists have studied this for years. We know all about the propensity of people to believe in things. It's called observer bias. I have a desire, if you will, to see a certain effect, and I will look for it in the data that I collect. And I'll sort of put higher emphasis on those things that agree with my personal prediction, and I'll de-emphasize those things that, raise a red flag. Right? We know that exists. I mean, that's why double-blind tests exist. Okay? So, let's go take a look. What are we really talking about here? So I've got a little block diagram. This box over here is our audio power amplifier. Loudspeakers over here, our signal source is back here, your CD player, MP3 player, whatever the heck you got. And then, of course, this thing gets plugged into a wall socket, which runs through some wire in your walls out to an AC entrance, a breaker box, which then goes out onto the street, right? So, this little dotted line here, this represents inside, outside, this is your home, your apartment, whatever. So let's just kind of walk through what's going on here. So we start off with AC power on the street. So the utility lines on the street are maybe, depends where you live, but, 10,000 volts, 12,000 volts, something like that. In North America, you will see these transformers sometimes on the ground, sometimes up on the poles, and they'll bring that down to, what you would expect, what's coming into your house at 120 volts, 60 hertz. If you're in Europe or some other countries, that's probably 50 hertz, and it might be 240 volts. It all depends on where you are. But really high voltage out here, it goes down through the transformer, and now you get what comes in here. So I'm just going to run with North American standard, which is 60 hertz at 120 volts. Okay, so that comes in through the entrance, the breaker box. And now that's running through typically maybe a 12 gauge solid wire. People use the brand name Romex a lot. That's the sort of blue color I have. So how long is that? Well, it depends on, where the breaker box is compared to where your stereo is. But, this could be tens of feet, 50 feet, 60 feet, who knows, all right, of this wire. Eventually that comes to a wall outlet. And then this sort of little green wire, this is the wire that's going into the back of your audio power amplifier, right? This is the juice from the wall going into your power amplifier. So what's inside the power amplifier? Well, I've highly simplified this into first a DC power supply, which takes the 120 volt, 60 hertz input and turns this into DC voltages, right? So I've split this out into two pieces. One comes down into this box I'm just calling signal amplification circuitry. So this would be the preamplifier. If you had like an integrated amplifier, for example, or a receiver, this would include like your volume control, your EQ, right? Bass and treble control, stuff like that, the switching circuitry, all that good stuff. And then I draw a second line out here to this transistor, which represents the output power stage. And I'm doing that separately because usually a power supply has to produce more than 1 volt, more than 1 voltage, excuse me. Usually we need a higher power supply rail for the output stage. But eventually that goes out to our loudspeaker, right? Highly simplified, but that's what we're looking at. So the thing that we're really focusing in here is this little green wire. This is the thing that they're telling you to go out and spend $500, and this is going to have a drastic improvement, right? This is what they claim. This is going to have a drastic improvement. We're going to ignore, maybe 50 feet of Romex over here, plus, who knows how much it's going out to the road. In my house, this is like 200 feet. It's like 200 feet of mostly buried cable going out to the street. What are we looking at in terms of the product itself? Well, here's one example. And the first thing I'm going to say is if you've seen my other video talking about audio cables, you know that this little diagram down here is just more stinky BS. This is meaningless. Before conversion, after conversion. What conversion? There's no conversion here. There's 120 volt, 60 hertz coming in on this end and 120 volt, 60 hertz coming out of that end. There's no conversion, right? These waveforms are meaningless. But this, notice two things. This does use Litz wire. And if you saw my video on Litz wire, right, on skin effect and Litz wire, you know the whole purpose of this is to extend the frequency response of the cable. So this produces low resistance at very high frequencies. Litz wire is good up to maybe a couple of megahertz. You'll also notice this has a shield. All right, that sounds interesting. Here's a different approach, right? Also has a shield, But they've kind of split this up kind of like a multi-way loudspeaker. In other words, they've made little bundles of conductors over here for different frequencies, right? It says one large, right, oxygen-free copper solid base conductor, right? So that's like, I guess, kind of like a woofer. And they say 3 different gauge mid-bass conductors plus 3 grade 1 upper bass conductors, right? So they've got, like, I guess, like a subwoofer and then a woofer and then like a mid-bass driver. And it says 2 different gauge, not the same, 2 different gauge high frequency conductors. So I guess that's like having maybe like a 1-inch dome tweeter, and right next to it is maybe like a 3/4-inch dome tweeter. I don't know, but that's what they're going after. All right, so they're kind of doing a slightly different approach. It's not clear if this is Litz wire. They don't specifically say that. Maybe it's not. It's just this idea of using different conductors. You know, the whole point of having different wires for different frequencies, it's not clear what would make one work better at one frequency versus another. You know, I have no idea. But let's get back to this. How is using the fancy wire over here going to help things? Well, let's look at the problem, right? You know, what are these things actually doing? You know, a typical DC power supply, the purpose of it is to take the AC input and turn it into a nice, stable DC output voltage. Typically more than one, you know, a low voltage for the low level circuitry and a higher voltage for the output circuitry, but still should be a nice noise-free, stable voltage. And there's actually 2 measurements we have for DC power supply performance, sort of coarse measurements, and that's load regulation and line regulation. So load regulation means how much does this voltage vary with changes in the load, in other words, as we're pumping out more or less current. And then line regulation is how much does this voltage vary as the input voltage over here varies. All right? Power supply should have really good line regulation and load regulation. It should also be low noise. Those are characteristics of a good DC power supply. It really shouldn't make much difference what's coming in over here, right? I mean, I'll grant an exception for extreme cases like if your house gets hit by, you know, a lightning strike. All right, all bets off, but under normal operating circumstances, what's out here really shouldn't make a whole lot of difference, right? As long as the power company is delivering you what's expected, in this case, North America, 120 volts RMS at 60 hertz, everything should be great, right? You get nice clean DC out here and out here. Well, what if it doesn't? Well, sure. You know, you might buy some inexpensive, you know, sort of knockoff amplifier or something. It's got a cheesy power supply design. Yeah, that's possible. But, you know, if you're a hi-fi audio enthusiast, an audiophile, you've probably spent a good chunk of change, maybe a few $1,000s more, perhaps, on your amplifier. It damn well better have a good DC power supply, right? If it doesn't, you got taken on the amplifier. It's that simple. Second thing is, the amplification circuitry over here, there's a parameter we really care about called PSRR, power supply rejection ratio. How good is this circuitry at rejecting noise and unwanted stuff on the power supply lines? Right? So, you know, you can look at operational amplifiers, for example, and find PSRRs, no problem, over 80 decibels, right? 100 decibels. Wow. That's the rejection of noise from the power supply. So this thing should be producing a nice signal. And even if a little bit does get out, well, this should be rejecting it as well. Okay? All right. But what about this? You know, what's the whole point of using a wide bandwidth, low resistance wire here? You know, it's kind of interesting to me. Like I said, this is maybe 2 meters, 6 feet. Over here, the Romex, which is, let's face it, not designed with any of this in mind. It's just a solid wire, right? I mean, this isn't Litz wire. This is just a plain old solid conductor. Like I said, maybe a 12-gauge wire. And there might be 50 feet of this. And then, now who knows how much is going out to the road, right? Same sort of deal. Why am I focusing on this last 6 feet? I mean, in reality, it's something you can focus on, right? You can go out and buy a replacement. It's easy. Who is going to rip open their home, rip open their walls to replace this? Not too many people. And even if you could, you still have all this going out to the street. You see what I'm getting at here? What's the point? It's kind of like saying, well, if this wire is so bad, let's just take that at face value, right? That these normal wires that you would use are just so inferior, right? That, they're going to degrade the signal that's coming into the power supply, and that's going to somehow leak into your audio signal. And again, I need to emphasize, audio signals aren't going through here, right? This is your audio signal path out here. This is the power supply that drives the circuitry, that does the amplification. Audio is not going through these wires, all right? So your precious music is not going through here. Precious music's going down through here. If we take it at face value that these wires are lousy, you would think, okay, well, if I improve this a little bit, maybe, that'll sort of leak through a little bit, Somehow there'll be a secondary effect. But how can you ignore all this? Right? I mean, to me, it's kind of like saying, well, Larry has a paper cut. So let's put a Band-Aid on that paper cut, while ignoring the fact that, unfortunately, Larry's leg just got chopped off, and, he's bleeding out like crazy. So I don't think the Band-Aid on the paper cut's going to do all that much. Okay? It's this stuff back here that you should actually be looking at. It's a small thing. This is a small thing compared to all this. And you say, well, every little bit helps. Well, yeah, I guess you could say that, but, there's sort of like levels of importance, okay? But I want to go beyond that. Is it even fair to say that having this wide bandwidth, low resistance wire is really going to make anything better? No, it's actually not going to make things better. Even if it does what it says it does, okay? And, I will grant you, yes, Litz wire does have a good high frequency performance. It does. I'm sure that if you took this cable and you measured its resistance at 100 kilohertz or 500 kilohertz, it would be considerably less as a percentage, right? Considerably less than the standard cable that you got with the amplifier. I have little doubt about that. Now, this one, I really don't know. I really honestly don't know, because, they don't indicate that this is Litz wire. They just indicate they have some different gauge cables in here. Maybe it is, maybe it isn't. I don't know. Maybe the shielding might help you a little bit with some noise that comes in, transmitted noise. I am not going to argue the fact that this thing should have a lower resistance. But is that really going to help you? Is that really going to help you? If you think about it for a sec, it actually makes things worse. Because here's the deal. To make the job of the DC power supply easy, what you want to do is deliver exactly what it expects, which is, in this case, 120 volts AC at 60 hertz. Nothing more, nothing less. So, if for some reason this waveform got distorted, or if there were, induced signals in here, little spikes and noise transients and whatnot, that makes the job of the power supply harder. I would like to get rid of those things. All of those things, like a little transient, all of those little things represent signals at higher frequencies. Right? So if you got a nice sine wave coming along, right? Here's your nice sine wave coming along, and you see some little spiky bits on it, little transient things coming on it. Those all represent higher frequencies. So the high quality cable is actually going to let that stuff go in easier than just the standard cable. The standard cable will not transmit a signal, in this case a noise signal, an undesired signal at 500 kilohertz, it's not going to transmit that through as well as the fancy cable does, right? The cheap cable in this case is actually better because you don't want that stuff coming into the amplifier. Like I said, you maybe could make an argument about using that kind of wire for your loudspeaker out here, but it makes no sense to do that for the power supply. All right, let that sink in for a sec. You're going to spend a lot of money to make things worse. Potentially to make things worse. Now, what I've discovered from many audiophiles, there is this sort of odd belief, maybe, I don't know what you want to call it, of purity. Everything has to be pure. Pure, pure, pure. It's a word you see a lot in audiophile hi-fi reviews. They talk about the purity of the signal chain, right? There's a lot of emotional baggage sort of tied in with this, okay? The purity of it. So the idea that you would have a cable, a special cable that has this fancy design so that it doesn't in any way impede the purity, doesn't degrade the purity of the AC power coming in. That's the whole point of this, right? And, the reality is, well, yeah, AC power is AC power. First of all, it's the job of the DC power supply to clean things up, right? But you don't necessarily want the pure, unadulterated stuff coming in here. I want to get rid of the crap. I want to get rid of the noise. What I would really like out here, if you think about it, is some kind of filter tap, like right here, that only allows through the 60 hertz sine wave that we should be getting from our power source. That would be the ideal thing, right? I don't really want a super wide bandwidth cable. That's crazy. That doesn't make sense. That's backwards to what we really want. Okay? So, you're going to pay a lot of money to make things worse. Let's sum this all up, shall we? So, the claim out front is that you could replace your stock AC power cord with one of these fancy cables and it will improve the sonic quality, right? And we argue that no, the job of the amplifier's power supply is to take that AC power signal and turn it into a nice set of stable DC voltages to drive your other circuitry. Okay? It should certainly not be adding any noise. Shouldn't be adding any transients or anything like that, or hum. Along with that, a properly designed amplifier has an appropriate power supply rejection ratio, so any noise that does come in from the power supply should be reduced that much further, right? Several orders of magnitude. And then we have to remember that behind the wall socket is tens of feet, maybe 50 feet or more, 75 feet, who knows how much, of plain old solid, Romex cable going out to your entrance. And then there's a whole bunch of wire that goes from there out to the street. Okay? So, you can't ignore that. If wire quality was really important, why are you ignoring, 90%, 95% of the total wire that's there? And, let's not even get into the wire that's going from the street, right, from the street transformer all the way back to the power source, okay? So, what you would really like to do is somehow filter the AC that comes in. Maybe you would like to have an uninterruptible power supply with filtering, right? I could see that. That might even help with something like a lightning strike. You have like a super duty surge arrestor thing so it doesn't blow up your amplifier. But that's a different thing. That's not really talking about audio quality, okay? That's not really talking about audio quality. That's more of a safety thing when you get right down to it. Hopefully, your AC power delivery is of higher quality and you really won't need that. But, I will grant that there are some people who live, in more remote areas and the power is not highly stable, right? It's maybe a little iffy, what have you. Something like that would be useful. But again, that's not just a power cable, And finally, we run along this whole idea of observer bias. So just a simple personal testimonial. Someone says, well, I listened to this amplifier. I owned it for a couple months, and then I bought this $500 power cable, and I put it in, and I listen to it now, and the soundstage is so much better. It's cleaner. It's crisper. On and on and on and on and on. You really can't put much stock into that, right? Observer bias is a real problem. Let's be honest. If you spend $500 on a power cable, $500 out of your pocket, you're going to hear a difference, right? Because you don't want to spend $500 and go, I just might as well just, put that in the fireplace, right? Because it doesn't do a damn thing for me. You don't actually have to do the test. Like I said, I don't have to go out and spend $500 for the special hat to put on my friend's head to see if he actually does survive having the 16-ton weight dropped on his head. I know what the physics are, right? We like science because it makes predictions. That's the whole point of it, right? That's the whole point of using the scientific method. We describe natural phenomenon, we understand the natural phenomenon, and it makes predictions, right? If it didn't make predictions, we couldn't do things like design electric circuits, right? We understand what the underlying theory is, and then based on that, we can design circuits because I have a predictable outcome. That's the whole point of the process. That sort of ability to predict what will happen because we have a solid framework, all right? So this whole idea really goes against what we really know, what we can check in lab. It doesn't make sense. It runs contrary to it. And if you're going to make an extraordinary claim, and I would count this as an extraordinary claim, you're going to need extraordinary evidence to back up that claim. And just a, heartfelt, yeah, I'm sure that's the way it is insufficient. All right. So bottom line, save yourself a couple of bucks. Don't worry about this. There's a million ways you can upgrade the sonic quality of your audio system if that's what you're into. This is not one of them. All right. All right. Take care. We'll see you next time.